All right. So thanks everyone for joining us for today's webinar, which is all about sampling. A key part of developing your data collection plan is deciding how many people you need to collect data from, and how do you choose who you will collect data from in order to accurately understand program outcomes and results. In an ideal world, we'd go to every single child, teacher, coach, and parent who's involved with Right to Play programs to gather information about their experience with Right to Play. But when you have thousands of children participating in Right to Play programs every week, it's just not feasible to go to each and every one of them and to conduct a survey or to involve them in a focus group discussion. So rather than collecting information from every child and from every coach and every teacher, you want to choose a smaller group of children, coaches, and teachers. And this smaller group that you choose to collect data from is what we call the sample. And I just want to make a quick clarification about the terminology. So the target population that you can see in the diagram here doesn't necessarily refer to the entire population in an area. It refers to the larger group that you're interested in. So for Right to Play, most of the time our target population would be the children participating in Right to Play programs. So when you choose your sample, you're choosing it from within that target population or from all the children who are participating in Right to Play programs, and not necessarily from all the people or children living in a particular area. And we're also going to talk about comparison groups a little bit later on as well. So how do you make sure that the data that you collect from the sample gives you an accurate picture of the target population? To do this, you need to make sure that your sample is representative of your target population. This means that the sample should have the same or very similar characteristics to your target population. And so, when you collect information about the outcomes and results from the sample, it should represent what is happening for the larger target population as well. There are two key ways to make sure that your sample is representative of your target population. You need to make sure that you choose a large enough number of people to participate in the data collection. And then you also need to think carefully about how you will select people to participate. And if at all possible, you want to select participants randomly. And while you want to make sure that you're as representative as possible, you also need to find the right balance between having a sample that's large enough to be representative without going beyond your budget and your available time. An important question to consider is how rigorous do you need to be? How deep is your measurement going to go? And how exact do you need to be in determining your minimum sample size? For most of our M&E work, sample size will be based on Right to Play sample size guidelines and the time and the resources that are available. Generally speaking, we're aiming to have a minimum of 400 participants in our survey sample, and we're gradually going to work up to 650 participants. I want to make a few comments about the Right to Play guidelines and how we've come up with these numbers. As you all know, we're trying to make our M&E work more and more rigorous so that we can take our measurement to a deeper level based on the globally accepted standards and processes for research and evaluation. So the globally accepted standards for determining sample size take into account three factors, and this is confidence level, the confidence interval, and the size of the population, which you can see in the yellow boxes to the right. For the purpose of today's webinar, we're not going to go into too much detail about confidence levels or intervals. But I just wanted you to be aware of the factors that determine sample size, and just to understand a little bit about what the research standards are, and that this is what Right to Play guidelines are based on. And if anybody wants to know more about confidence levels and intervals, feel free to email Colleen and I, and we can get into more detail about that. Another thing to be aware of is that most researchers who need to calculate sample size based on confidence levels use websites that are designed exactly for that purpose. And there are lots of websites that will do this for you, so you don't actually have to do complicated calculations on your own. And just as an example, this is the one that we use at Right to Play, www.surveysystem.com. And what you do is you just plug in your information and then you hit calculate and it'll give you your minimum sample size. But don't get too hung up on the sample size calculations, because if you follow the Right to Play guidelines, you'll be close to the 95% confidence levels, and you won't need to worry about doing the sample size calculations. So now a little bit about random sampling. With random sampling, each person in the target population has the same chance of being selected for the sample. And in this way, the sample is likely to have the same range of characteristics or experiences as the target population. So it's a way of making your sample representative. Random sampling is very important for reducing selection bias. So selection bias happens when certain types of individuals or certain characteristics are either more likely to be included, so that's known as overcoverage, or they're less likely to be included, which is known as undercoverage. And there are basically two main ways that selection bias can affect your sample. Or I should say that there's two main ways that it can be introduced into your sample. One way is bias on the part of the researcher. So these could be conscious or unconscious choices by the researcher, by the M&E officer, by the program manager, in terms of who they choose. And it could be that they're just inclined to choose children who attend Right to Play programs more often, or maybe they attend school more often. And the result would be that there are more children with high attendance and positive outcomes, and less children with poor attendance or the less positive outcomes. So, in that way, your results might be a little bit skewed, where you have more information about the children that are doing well in the programs or that are maybe just doing better on a number of different things like school or family or other factors. And that doesn't really give you a complete picture of your program outcomes, because you want to understand the outcomes with all children so that you can make your programs more effective across the entire spectrum. When it comes to the respondents themselves, there can also be bias in terms of who is willing to participate or who is able to participate, because some children might be more outgoing, they might be more involved with Right to Play programs. There might be kids that are just always the first ones to raise their hand or to volunteer to participate in something. And outcomes for these children might be very different than the less outgoing or the quieter children. On the other hand, it could be related to their ability to participate. So, for example, some children might have a really supportive home environment where they have a lot of leisure time and they can participate in the programs. Whereas other children, maybe the home situation isn't quite so good and they have a lot of responsibilities. And so they have less time to get involved with Right to Play programs, or maybe they have less time to go to school, or all kinds of things like that. Another point about randomization. There are a lot of different things that you could randomize. These are known as our units of randomization. So, for example, you could randomize the schools or the communities that you go to, or you could randomize the individuals, such as the children or the youth or the adults that you choose, or in some cases, you might randomize the households that you go to. In Right to Play, in the survey that we're doing, we're primarily going to use schools as the units of randomization, but for the purposes of this webinar, I'm going to use examples of randomizing both schools and children, just to give you a bit of a broader perspective on randomization. So I'm going to take a brief break right now to see if there have been any questions that have come in. All right, looks like no questions so far, so we'll carry on. Now we're going to move on to talking about the sampling methods themselves. To start with, we're going to talk about a simple random sample. So this is the easiest way of doing a random sample. The first thing you do is you make a list of all of your units in the target population. So the units might be the children, might be the schools. And so what you would do is you would take every child's name or every school name and just put it in a list. The easiest way to do this is to use Excel. And I would recommend using Excel rather than Word for this. And I'll explain more about that in a little bit. The second thing you need to do is determine your sample size. So how many units or participants or schools do you need to collect data from? So for example, in the Right to Play guidelines, we're aiming for 400 to 650 children, depending. Then you randomly select units from your list, and there's two ways that you can do this very easily, and I'm going to go through both of them. So the first is you can manually choose from the list, and the other way you can do it is by generating a random list in Excel. So let's start with looking at how you manually randomly select from a list. So based on the target population and the sample size, you need to calculate the interval that you'll use to select units from the list. So for example, you're going to select every X number of names from the list. So to do this, it's a very simple calculation. You just divide the target population by the sample size, and that will give you your interval. So for an example, let's assume that our target population has 1,089 children, and we want a sample of 400 children. You simply divide 1,089 by 400, which gives you 2.7. And of course, 2.7 is not an easy number to use to choose names from a list. So you just round up. And so the interval is approximately 3. And then you would choose every third child from the list until you reach 400. Once you have your interval, it's actually best not to just start at the top of the list and start counting off every third child. Ideally, you want to start at a random point on your list so as not to bias it. For example, you might bias it if the names are listed alphabetically, or maybe the schools are listed by geographic area or something like that. So if you start at a random point on your list, it just reduces any sort of selection bias that could be introduced at that point. The easiest way to do this is to go through a website such as www.random.org, and you simply plug in the numbers, so your minimum, your maximum, and our maximum in the example is 1,089. You hit generate and it will give you a random number. So in this case, it gave me 609. So we're going to use 609 as our starting point. So what I have on the right-hand side here is just a hypothetical list of names, and we're going to assume that there are 1,089 names on the list. The nice thing about Excel, of course, is that it numbers every item on the list. So you scroll down, you find 609, which is your random starting point, and then from 609, you start counting every third child, or whatever your interval happens to be. And as you can see, in my list here, I've just taken the names that I want to select and just highlighted them so that I know which ones to include. Now, if you're going to manually randomly select from a list, there are a few things that you need to consider to make sure that you don't introduce any bias into your selection. So first of all, you need to make sure that you're consistent with the interval between units. So in this list, as you can see, every third name has been chosen. As you're going down the list, you shouldn't for any reason skip over a name or choose a name that's not every third one. Because whatever your reason, whatever your instinct is for doing that, it's likely to introduce a small bit of bias into your sample. And we want to make sure that everything we do reduces bias, and that's the whole purpose of randomizing the sample to begin with. The other thing that I had mentioned earlier is that you want to consider the order in which the units, so the order in which the schools or the children are listed on the list. So if they're alphabetical, or if they're by geographic area or length of involvement with right to play, ideally what you want to do in that case is actually randomize your list before you begin selecting, so that you don't end up overrepresenting any particular characteristics. And this can be done quite easily in Excel, and we're going to go through all of this in the next portion. So now I want to talk about how you generate a random list in Excel. So you would do this if you don't want to manually go through and choose every third or every fifth name on the list. And this is just a little bit easier because Excel just offers some handy little tricks so that you can randomize a lot quicker, and so that you don't have to sit there circling every third name, and so that you don't have to print out a lengthy list. So my recommendation is, if you can learn to do it in Excel, you will save yourself a lot of time and a lot of tedious work. So in this example, we have a list of 15 schools here. And let's say that we want to randomly select 10 of them. What you would do, starting at the top in a column beside your list of names, you want to type in the formula that I've got highlighted in the box here. So equal signs, RAND, and brackets. And this is the formula to generate a random number in Excel. When you hit enter, a random number will be created, as you can see in the right-hand column, column B, which is called random number. Make sure that you label the column so that you know that it's a random number and not your data. So when you're going back to this list later on, you don't get confused about, okay, what does 0.7485 mean? What you do then is you go to the random number that you've just generated, and there's at the bottom of the cell, you'll see there's a small green box. So if you click on that and if you drag that down, you'll copy the formula into the cells below, and this will generate a random number for each name on your list. And you don't have to type in the formula for every single name. What you do next is you go to your data tab, and you'll see I've circled that in red in the top right corner. And on the data tab, you'll select the button for sorting. And it doesn't matter if you sort in ascending or descending order. And it's a little bit small on the screen, so I've just put the sort function here in green. And what this does is that it takes all your random numbers and the associated names, and it'll sort them in the order of the number. And so in this way, your list of names has just been randomized. And in our example, we want to choose 10 out of the 15 schools. So we would just go to our list that's just been randomized and take the first 10 names at the top of the list. And this will end up being our randomly selected sample of schools that we want to then go and survey. All right, I'm going to stop now for questions. Okay, so I have a question for Wafa about a simple random sample. And what if the child's name is not there? Do you automatically take the number below that space? And would you skip every third child in that case? Okay, if for some reason you're missing the name, or for maybe you're missing some kind of detail that you need about a child, go through your list beforehand, see how many names are incomplete or how many names you're missing. And before you even select your sample, try to get the names and the information that you need in order to find that child. Because this is a good example of, cases where you don't know the situation with that child, and maybe the situation is that they haven't been attending school or the program as much, and the record isn't as complete for this child. And ideally, if you can get that information, you might want to include them. And whether they'll get chosen for the sample or not, that doesn't matter, but you need to make sure that they have the same chance of being selected. And if they're selected, you have to be able to find them. If, however, you can't find the child's name, you can't find their complete name or where they're from or which school they belong to or any other key information, if there's absolutely no way of getting that information when you follow up with your program staff, then you can take the name off the list, because you don't want to have names in your sample that you can't find, and you don't want to have children that you spend a lot of extra time and effort finding. Like, you do have to make sure that you can actually get to as many individuals in your sample as possible. Yeah. All right, I have another question, so I'm just going to try to unmute everyone. All right, Sarah, go ahead.
Hi, I'm wondering, from the list that you generated, there are many of the communities we work with. Some of them are geographically much further to travel to than others. So in terms of the random sampling method you've used, they all have an equal opportunity. The trouble is taking budget into account, and if there isn't the capacity within the community to administer the survey or whatever it is, the method that's being used, it might cost a lot more to travel to one of the communities to do the M&E work than another. And so it could be a constraint that we might not be able to accommodate.
Mm-hmm. That's a really good point. I'm just going to mute everyone again while I answer so that we don't get feedback. Um, Absolutely. There are a lot of considerations that you need to take into account when you're selecting your sample. And you do have to find the right balance between what's actually feasible. What do you have the time and the money and the capacity to do? And how representative can you be within those constraints? So what you would actually do initially is you might, from within your target population, you might make a bit of a smaller list and say, well, here are schools that we can actually get to. And these schools we're going to have to take off the list because we don't have the time and the money to do it. If you do that, it's not ideal. Your sample won't be as representative. But if you explain all of this in any reports that you write or in your methodology or anything like that, as long as you're really transparent when you have to make choices like that because of different constraints, that makes it a little bit more okay. In that case, you wouldn't be able to say that your sample is representative necessarily of your entire target population, but you could say that your sample is representative of a smaller subset within your target population. But you're absolutely right. There needs to be a budget consideration and time considerations and capacity considerations as well. All right, we'll carry on, and we'll have time for more questions in a few more minutes. Oh, the other thing that I wanted to say is that I hope that our short Excel tutorial that we went through about generating a random list in Excel has been helpful and that I haven't gone too quickly. And if anybody wants me to go through it again, if you could just type in R, just the letter R, into the chat box, what I'll do is I'll go through this again at the end of the webinar once the recording is turned off. So if you think you've got it, if you think the PowerPoint slides are enough, then don't worry about it. But if you do want to revisit this specifically, just type in the letter R. R like random. Okay, so we just went through how you do a simple random sample. But we also want to spend some time today talking about multi-stage random sample designs. So these are a little bit more complex. This is what you do when you want to randomize on a few different levels. So quite simply, multi-stage random sampling is any kind of sampling that's carried out in stages where you use smaller and smaller sampling units at each stage. In a two-stage sampling design, what you do is you sample primary units, and then you select your secondary units from within the primary units that you've selected. So for example, in a two-stage random sample design, the first stage of randomly selecting might be the schools that you select. Once you've randomly selected schools, the second stage of sampling would be to randomly select children within each of the randomly selected schools. So there are basically two types of two-stage sampling designs where you just go through the two different steps. One is cluster random sampling, and the other is stratified random sampling. Now, they're both very similar, but there are small but very important differences between the two methods. So we're going to go through both of them. With the cluster random sample, the primary units are chosen based on a simple random sample, like we just did, and then that's followed by a census of the secondary units within the primary unit. So what that means is that you randomly select your primary units, and then you end up going to survey all of the secondary units within each of the primary units. I'm going to go through some examples so that everyone can see exactly how this works, but just bear with me as I go through the actual technical definitions. In a stratified random sample, the target population is divided into separate groups, which are known as strata, based on certain characteristics or criteria of interest. Then primary units are selected within each strata, and after that you do a simple random sample to choose secondary units from within each primary unit. Now, it's also possible that you can go beyond a two-stage sampling design and you can have a multi-stage sampling design, which is basically doing a stratified random sample, but stratifying multiple times. So instead of just doing it twice, you could do it 3 times, 4 times, 5 times, as many times as you need to. Basically, the target population is divided into separate groups known as strata, again, based on the characteristics or criteria of interest, and then primary units are selected from each strata. Then the primary units are divided into different strata again, based on other characteristics or criteria, and then secondary units are selected from within each of these strata. And then from there, you might stratify again, and then your tertiary units are selected from that next level of sample until you get to your final level of stratification or selection. So basically until you get to the individual level. So now I'm going to talk about each of those 3 sampling designs in a lot more detail. So for the cluster random sample, where the primary units are chosen with a simple random sample, and then this is followed by a census of secondary units within each of the selected primary units. To do this, you start by identifying your primary and secondary units and the sample size for both. So as an example, let's say that we want to select schools as our primary unit, and then from within each school, we want to conduct a survey with children. So our primary unit would be schools, and in terms of the sample size, we know that we need to select 20 for our particular measurement purpose. In terms of the secondary unit, we know that we want to survey, or that we need to survey, 400 children in grade 1 across those 20 schools. So the first thing you do is a simple random sample of the primary units, in this case the schools. So this is exactly what we did just a few minutes ago. First, you generate a list of the units. So you put together a list of all the school names that are eligible in your target population, all the names of schools that you can realistically get to. Then you determine the number of units that you need for your sample. In this case, we need 20 schools. Then you randomly select those units. So you randomly select the schools using one of the 2 methods, either by doing it manually, by choosing names from a list based on an interval, or by generating a random list in Excel to choose the number of schools. So just in terms of calculating the interval, once again, you just take your target population. So for example, maybe there's 60 schools that you're working with. And if you want 20, then you divide the 60 schools in your target population by the 20 schools for your sample, and then you get 3, which is your interval. So then you would select every third name on the list. Or you can skip all of that interval calculation and you can just go right to Excel and have Excel generate the random numbers for you. So once you've selected the schools or your primary units, then you need to do a census selection of the secondary units. And in our example, this would be the children at the schools. A census style selection is when you collect information from all of the units, so from all the children, rather than selecting a sample. So in our example, once we've selected the 20 schools, we would then go to all the grade 1 students within those 20 schools. And if we assumed that there were approximately 20 students per class, and we were able to find all of them for the survey, that would give us approximately 400 surveys. And our desired sample size of 400 children is reached, which is pretty easy and pretty straightforward. Does anybody have any questions about the cluster random sample design? All right. In that case, let's move on and let's talk about the stratified random sample. So in this case, in this sample design, our target population is divided into separate groups, which are known as strata, based on certain characteristics or criteria of interest. The reason that we want to do this is that stratifying helps you make sure that all subgroups within the target population are represented in your sample. So here's a list of different characteristics or criteria that might be of interest to you. So for example, rural and urban, or maybe you want to make sure that you have a representative number of affluent and disadvantaged or poor schools or children. Maybe you want to make sure that you have both secure areas and conflict affected areas. Maybe there are different ethnic groups in your target population and you want to make sure that all the different ethnic groups are represented as they would be represented in the population. So you can stratify by just about any type of characteristic or criteria. It just depends on what's relevant and what you think might have an impact on your program. And what you want to do is think about characteristics, particularly if there isn't a 50-50 split. So let's do a little example. Let's say that our target population is primarily rural, maybe 80% rural, with a few small urban areas. So maybe 20% of the population lives in towns or cities. By stratifying our sample to make sure that we include 20% urban and 80% rural in our sample, this will help ensure that both rural and urban are represented based on the actual proportion of urban and rural that's found in the population. So now that we've talked about why you want to stratify, let's talk more specifically about how you stratify. So you start by identifying the strata or groups of interest and the units of randomization, both primary and secondary, and the sample size. So in our example, let's say our strata is urban and rural. Our primary units are 20 schools, and our secondary units are children in grade 1, and we know that we want 400 children, and we want 20 schools. The next thing you need to do is determine the proportion within each strata so that your sample will reflect the target population. So in our example, we're working in an area where it's 20% urban and 80% rural. So you want to make sure that your selection of schools represents the 20% urban and 80% rural split. In our example, we want 20 schools, And so this means that we would want 4 urban schools, which is 20%, and 16 rural schools, which works out to 80%. What you do then is just like the other designs that we talked about, you make a list of the units in each strata. So, for example, you list all the schools that are urban and all the schools that are rural within your target population. Next, you use your simple random sample method to select the primary units within each strata. So you randomly select urban schools and you randomly select rural schools. And again, the way to do this is exactly the same as what we talked about earlier. You either manually select the names from the list or you generate a random list in Excel. Once you've selected your schools or your primary units, then you randomly select the secondary units from within each primary unit. So you randomly select children from within the randomly selected schools. And once again, it all comes back to the simple random sample. So you go back and you do that same thing where you list out the names of the children at each of the schools that you've selected, and then you either manually select the children or you generate a random list in Excel. So as you can see, there's a bit of a pattern here. And even though there are some key differences between the designs, there's a lot of similarity and a lot of overlap. So are there any questions about stratified random samples? All right, looks like there's no questions. So now we want to talk about a multi-stage random sample. And multi-stage sampling basically is just a more complicated way of doing a stratified sample. So you just stratify it multiple times. And each time you stratify, each time you sample, you're using smaller and smaller sampling units at each stage. So if you're doing a multi-stage random sample, you do have to start with a fairly large number in your sample to work down. And as you work down, you need to make sure that you're going to have enough to satisfy your sample size. So for example, let's talk about some different strata. Let's say initially you want to group your sample by urban and rural, but then within rural and urban, you want to make sure that you accurately capture both affluent schools and children as well as children in schools in less affluent areas. So then you would stratify again by affluent and less affluent. And maybe within that, you then want to make sure that you capture children in schools that are in a secure area and those that are in a conflict affected area, and so on and so on. And you basically just keep stratifying within each group and just kind of breaking it out that way. The process for doing this is very similar to what we've already talked about. For your first strata, for example, urban and rural, determine the proportion in your actual population. Then you make a list of units in that strata. So for example, you list out the urban and the rural schools. Then you randomly select units from within each of the strata. So you randomly select schools from the urban list and you randomly select from the rural list. And you do that separately. So each list gets its own simple random sample. And then once you've selected your urban schools and your rural schools, from within those schools, you stratify again. So you take that list that you've selected and you go through your second stratification. So this time in our example, we'll do affluent versus disadvantaged. First of all, you determine the proportion of affluent versus poor in your larger population. So let's say that it's 30% who are affluent and 70% who are poor. Within the first strata, so within urban and rural, you make a list of schools in the second strata. So you list out those schools that you've selected that are affluent and that are disadvantaged. And as you can see here in the list, you do that separately for urban schools and then separately for rural schools. And then from within each of those lists, you now have 4 lists, you randomly select the number of schools that you need in each sample strata to represent the population. So it should be 30% affluent and 70% poor within your urban category, and it should be 30% affluent and 70% poor in your rural strata. And again, you can do this either manually or by using Excel. And then if you wanted to stratify again, you would go through that exact same process again. And for each of those new groups or the new strata that you've generated, you would go and you would stratify that again, maybe by secure versus conflict affected, or by ethnic group, or any other characteristic that you think is important to consider in your sampling. And you keep on doing this until you get to the point of actually choosing the individuals or the children. And once it comes down to the children, you can either do another simple random selection, or if possible, you can also do the census style sampling where you just go to every single child that you've chosen. So just to recap, here's a bit of a summary of the 3 different methods that we've talked about and the similarities and the differences. So as you can see, the cluster random sample is the simplest, where you use a simple random sample to select your primary units from the target population, and then you go to every single one of the secondary units within the primary unit. The stratified random sample is just a little bit more complicated because you first divide your target population into strata based on characteristics of interest. And then your primary units are selected using a simple random sample from within that strata. And then your secondary units are selected using a simple random sample from within each of the strata that you've identified. The multi-stage random sample is basically just a stratified random sample where you stratify multiple times instead of just in 2 stages. So you have your initial strata, and then you select your primary units from within your first strata. Then these primary units are divided again into a different set of strata, and the secondary units are selected from within the second strata. And then you can divide it again where you select tertiary units from within a third strata, and you keep stratifying until you get to the point where you're ready to select the individuals, either by census or by doing a simple random sample. Does anybody have any questions? All right, looks like there's no questions. So let's carry on. So I've gone through a lot of examples of different sample designs. And it all probably seemed quite straightforward in the examples that I was using, but all of you have been involved in collecting data and doing surveys with schools and with children. And it's often a little bit more challenging, and sometimes it's difficult to stick to the sampling design because of different challenges that come up. So with right to play data collection, ideally we're trying to survey all the children in a particular class with a census approach. But things happen. For example, students are absent, you might not have enough time to survey the entire class, or you might run into cases where teachers try to choose which students to involve in the survey. And so that can really throw a bit of a challenge into your sampling design, because all of a sudden you've gone from trying to choose every single child in a class to a situation where you actually can't choose every child in a class. In terms of students being absent, in your data collection plan, if you possibly can, allow for extra time for follow-up so that you can come back to the students who were absent in the first round. And this can be a huge challenge because we're always trying to collect data as quickly as possible. Usually we're trying to collect data from different sites, so it means you have to travel from one to another, and going back can take up a lot of time and resources. But it's rare that you're going to go into a school or into a class where all the children are actually present. And the thing is that you don't know why particular students are absent, and you don't know if this may be connected to their school outcomes or their program outcomes or anything else. And so you really want to include these students who are absent, and to really understand what's happening and how do the other factors in their life affect their outcomes. In terms of not having enough time to survey the entire class, this is one of the reasons why piloting the surveys is so important, because it gives you a bit of an idea of approximately how much time is going to be required to do a survey. And so ideally, you want to pilot with children in classes that are the same age and the same level and the same size as where you're actually going to be carrying out your survey, so that you have a realistic idea of how long it's going to take. And of course, if you can, you want to pilot in more than one classroom, because there's always cases where one classroom might take a lot of extra time or a lot less time. And you just want to make sure that you have a really accurate idea of how much time it could actually take. Of course, you also want to plan extra time in case there are delays, or in case you have a class that just requires more time. Maybe you have a class that ends up being a lot larger than others. Or maybe you just have one of those classes where the kids are really energetic and it's just harder to get them to sit still and focus than in other classes. You just never know what you're going to run into. So if you can plan contingency time into your data collection plan, it will save you a lot of aggravation, and it'll make your sampling a little bit more representative and accurate. In terms of teachers picking which students to involve in the survey, well, we already know that this is a really serious type of selection bias, and it's a very real one, and it happens all the time. So you also need to consider how you're going to explain the survey to the teacher, and really make it clear that you're not there to evaluate them, and that you want to understand the entire range of program outcomes among the students. And so you need to include everyone, and that includes the children that might be a bit more troublesome, or the children that aren't doing as well, or that don't participate as much, because you need to understand the full spectrum of outcomes and experiences with the program. Now we're going to talk a little bit about non-random sampling. When you're doing focus group discussions or interviews or other qualitative methods, we generally aren't able to fully randomly sample. And there's a number of different reasons why randomizing in qualitative research is a little bit more challenging. For example, most of the time you're working with much smaller samples for your interviews and your focus group discussions. And one of the reasons for this is that qualitative research often takes a lot longer per participant. And so if you're doing an hour-long interview with a number of different people, I mean, you just can't go to 400 people and do an hour-long interview. And so the random sampling approach just isn't feasible, and it's just not practical. And of course, it also depends on the availability of participants, because, as I mentioned, qualitative research often takes a lot longer. And so you do have to be really respectful and understanding of participants' availability and their willingness to give you that time. Of course, you want your qualitative samples to be as random and representative as possible. Now, sometimes when you're doing interviews, it's really easy to actually interview everyone that you want to. For example, if you're trying to do some kind of partner assessment or research with your partners, it might be feasible that you can go to all the different program staff or the volunteers of a small organization, and you can talk to everybody. But if you're trying to do focus groups with parents or with teachers, where there's actually a large number of people that you could possibly involve, then you might want to consider how you can use some of those randomized approaches and how you can bring that into the qualitative research to see if you can make things a little bit more representative. So as I mentioned, non-random sampling can be really effective in some types of qualitative methods, but you really don't want to use non-random sampling for survey research if you want a representative sample. If you do a survey and you can't randomly select, and you have to make selections based on a non-random design. Make sure that in all of your reports or anything that you write about the results, that you always state this very explicitly, so that people don't draw conclusions that they shouldn't, because it's not a representative sample. So just very briefly, there are four main kinds of non-random sampling. The first is convenience sampling, where basically you just go to the people who are available or who are close by, or maybe the people who are at a school in a particular day, and you ask them to participate. So for an example of convenience sampling, it may be at the end of an event, you want to get some feedback and you have a short survey to see what people thought of the event. And you might just go and ask the people that are nearby or the people that have stayed to the very end just to get some feedback. This is not representative. That's just an example of how convenience sampling is sometimes used. Snowball sampling is where you start with a few participants and then you ask them for recommendations on who else might be a good informant. This is a particularly useful approach when you're doing interviews, particularly with partners or with other stakeholders, and you're talking to somebody and you want to understand who they think might have important information for you. And so you take recommendations. And this is particularly good if you don't know the partners that you're working with all that well, or if you don't have a complete list of relevant informants at the outset. Judgment sampling is when the researcher uses their own experience, their own knowledge of the population of interest to select participants. And quota sampling is when participants are chosen until the sample size is reached, but ultimately the researcher decides who to include, and it's not done randomly. Does anybody have any questions? I don't know if that's a good sign or a bad sign that nobody has any questions, but let's carry on. So the last section of our webinar is about control groups. So why do we need control groups? Well, quite simply because we need to understand the differences between children and communities who have participated in Right to Play programs and those children and communities who have not participated. It helps us to understand the links between the program and the outcomes, and to really get at the question of whether or not the program really improved the situation for the children, or if improvements were the result of other factors. Control groups should be very similar to the intervention group or the group of children in the program in terms of demographics. So when you're choosing your control groups, you want to consider geography, economic status, ethnicity, any other factors that you think might be relevant and might have an impact on any level on your program children. The control group should only be different from the program group in that they haven't had any experience with the intervention. So they should have absolutely no experience with Right to Play programs or activities. And so the children in the control sites should be far enough apart from the children in the program sites so that you can ensure that the children who are participating in the program are not teaching or interacting with these non-program children, because this can really skew your results. And you might not even think that it's a big deal, but if children inadvertently do have exposure to some of the messages in the program, then you can't really fully understand the difference between program and non-program sites. And then your control group won't really represent children who have not participated. So in order to select your control group, you first of all need to identify the key characteristics of your intervention schools. So this could be things like geography, economic status, ethnicity, any other type of characteristic. Then you want to identify schools with similar characteristics that have not had any exposure to Right to Play programs. And like I mentioned, ideally, you want them to be located pretty far away from where the Right to Play programs are located. And then you randomly select control groups using the very same method that you use to select your program schools. So for example, you might do a simple random sample, a cluster random sample, stratified sample, or a multi-stage sample. And that pretty much covers it for control groups. Does anybody have any questions at this point? All right. Okay. Okay, hold on 1 second. Okay, there's a question.
Hi, it's Sarah here. I'm curious with the control groups, how you would go about accessing consent in order to have them participate in the program if you're looking for people who have no experience with the Right to Play program. So why would they want to participate and what benefits would they receive from doing so?
That's a really good question. And there's a lot of ethical things that you need to consider when you choose your control group. Like, for example, what right do you have to go into an area where you're not providing any support and asking really personal questions? What most organizations do is they select control areas or control groups in areas where they hope to expand the program to. So, in that way, eventually those groups will benefit from the program, and it can provide a bit of a baseline as well. And that's one way that you can get, or you can address some of the ethical issues with doing that. When it comes to research with children, I mean, this is always a very challenging thing. But that's kind of the generally accepted way of addressing some of that. And other than that, I mean, there's not really any other good ways of doing it, or getting around that. Are there any other questions?
Can I ask a question that goes earlier before we talked about control groups?
Sure.
So when you were talking at the very beginning about the sample size for Right to Play and the standard being 400 to 650, could you talk us through a little bit how you arrived at those figures?
Yeah, and I wasn't the one who actually did those calculations, but when you get to 400, 400 is a pretty large sample size, and that's for the types of populations that we're working with and for the size of our programs. 400 to 650 will be within the 90 to 95% confidence level most of the time, probably 99% of the time. And so that's kind of an acceptable range where we know it's going to be the bare minimum, and it's enough of a range that we don't need to do specific calculations for each population, and it's big enough that it will cover us off with sufficient rigor. Are there any other questions? All right. Well, I guess we'll end things there. Thanks so much to everybody who joined us. And as always, let us know if you have any questions. And we're going to put the PowerPoint and the recording on the portal in the next few days. So if you want to go back and look at anything, it'll be on the portal for you.
Thanks, everybody.
Bye for now.